Hello, and thank you for listening in on our 2018 Chicagoland workshop recordings. Our first presentation is on lift stations and force mains. We will have a panel of presenters presenting this session. In the live mode, we did some interactive polling and had some questions to think about, well, in advance of this presentation. So very briefly, the first question was if you have lift stations. Pretty simple question, but something to kind of take a minute and think about which stations and what kind of stations you have. And the next question was, what was the first word that comes to mind when you think of lift stations? So we did this and have a number of different answers there. No wrong answer, obviously, but a lot of people have a lot of different opinions on lift stations. So thinking about your opinions, hopefully we will give you some interesting things to consider when evaluating your current lift stations or planning retrofit, rehabilitation, or new designs. So what brings us to talking about lift stations and force mains, and what are some issues that commonly exist when discussing them? Well, first on the design side, a lot of times these lift stations have been designed and constructed by developers and may have been turned over to the city or community or sanitary district with little oversight or guidance, not giving the community an opportunity to have a large say in what it will look like or even how it will be operated in the future. A lot of older designs also have unsafe designs that require confined space entry into even dry wells, and there are a number of concerns with corrosion and toxic environments with regards to those. On the operations and maintenance side, a lot of older lift stations have inefficient pumping, whether the impellers are worn, there are improper settings on the operations side of things, or maybe improperly calibrated sensors and those and floats. Also on the force mains, they're very difficult to clean and inspect, and oftentimes gone out of sight and out of mind, even more so than the gravity sewers, because they don't have entry points into the visual inspections like a manhole to look at a force main. And then from a sustainability standpoint, the electricity cost is approximately 85 to 95% of the operation and maintenance costs for lift stations. So power consumption is a very large contributor to municipal costs, especially communities that have a number of lift stations. And failures in lift stations can result in overflows and basement backups, and obviously that is not of interest to anybody, both from the environmental standpoint and personally. So today we're going to be talking about this panel discussion. Our first presentation will be David Edgren, who will be discussing lift station condition assessments as a whole and how we look at a lift station to help understand how it's being operated and what may or may not need to be done to rehabilitate it. Then we'll be talking about some design considerations with Jan Gallen and operation and maintenance considerations from Mike Stone. Our last two presentations in this panel discussion will be a case study about a 16-inch force main in the village of Hanover Park, Illinois, that had a break and an interesting story of how we've gotten to where we are at today on that inspection program. And then Andy Detmer will be talking as the last presentation on force main condition assessments as a whole and how to build a program to look at force mains within your community. A quick look at our panel presenters here. They were introduced on the last slide. And with that, I would like to turn things over to David Edgren as he discusses his program for lift station assessments. David?
Thanks, Zach. Thank you for joining us. I'm excited to be here and to talk to you about lift station assessments today. So I call this lift stations. They're a small piece of a typical collection system, whether that's sanitary lift stations or whether it's storm. Maybe 5%, 2% is made up of lift stations and force mains, and the other like 95% of your system is just gravity pipes. But the lift stations are some of the most complex, probably the most complex piece of your collection system. Think about it. If you have a new PVC pipe, maybe you go out there and you televise it once every 10 years or so. If you've got a lift station, you're probably out there every day, every other day, maybe at least once a week, checking on that station, making sure that it's operating like it should. So we've gotten into lift station assessments, partially, I know some of you are NWRD communities, and the INI control program. This is lift station assessments are one of the 6 mandatory pieces of the short-term requirements for the NWRD IICP. So, this is something that we've gotten into partially with that, and also just partially trying to understand, our goal of lift station assessments is to ask, is this station designed well, and is it operating well for you, the owner? And that's really our goal with lift station assessment. So today I'm gonna give you an introduction to assessing your lift stations, and we'll look at what is a lift station assessment, what are some of the things that we do when we come out on site, and then I want to give you some ideas of what can you be doing in-house and what are best practices for lift station operation and maintenance for you, the owner. So we'll kind of just take a broad look at assessing your lift station, and again, just knowing, is this lift station designed well? Is it operating well? So you can be on the lookout here. I was pretty proud of this. We managed to get 23 different lift stations represented here in the photos in this presentation, just in mine. So you can keep an lookout for that. So I'll show you a whole bunch of different lift stations from 23 stations from 13 different communities. So you can be on the lookout for yours here. So components of an assessment. So the 3 things that we'll do when we go out there. First one is hydraulic assessment. Second one is structural and INI assessment. And then the third one is operational assessment, or a checklist that we go through and collect data on the lift station and look at a whole bunch of different parts. So we'll take each of those one by one and we'll look through them. So first of all, hydraulic assessment. This is the first thing we'll do when we come out on site, and we'll ask, are the pumps pumping what they are supposed to? So here down at the bottom here, I'm showing a pump curve. We've actually got 2 pump curves, showing when this pump station's operating with 1 pump and 2 pumps. Then you've got the blue line there is the system curve, and you can see where those intersect. That's the flow in the head that pump is going to be operating at. Now, we could bring a pump guy in here, and he could talk, all day about pump efficiencies and where it's operating on the curve, and net positive suction head, and all these different pump terms here. But I'll just kind of simplify this, and basically, here's how I like to think of it: is you've got your pumps, and you've got your piping or your system, and those two they're designed to work together. So you need to size your pumps for the system that you have, so that your pumps can actually operate efficiently. They play together. So what are some of the things that we're looking at when we're out there, assessing the hydraulics of the station? And we get into a lot more of the weeds. So one of the first things we look at is pump elasticity. I think this is a good term for it. Is pump elasticity is what say you have 1 pump running, and that pump pumps 100 GPM, or 100%. Then let's say you turn a second pump on, you're not going to get double the flow through that force main. You're going to get somewhere between maybe 120% or 190%. Maybe 120 gallons a minute, maybe 190 gallons a minute flow through there. And that's your pump elasticity. And the pump elasticity varies a lot depending on your force main. So if you've got a really long force main with a lot of friction loss through that force main, then your pump elasticity is going to be on that lower end, maybe 120, 130, 140 at most. If you've got, say, just a really short force main, and maybe it's this pump station's just pumping it over into the next manhole, then you're going to be up in the maybe even the 180s, 190s in terms of what you're able to pump through there. Another aspect that we'll look at is force main velocities, right? You get too low velocity, below about 3 feet per second, and settling starts to be a problem. and if you get above, say, 8 or 10 feet a second, then you start to have some concerns about scouring or your pressures being too high and excessive force main breaks. We'll look at the wet well detention time, because that plays an issue with H2S buildup. If you let that flow sit in the wet well too long, it's gonna build up some H2S. And we'll also look at pump starts. This is less of an issue with newer pumps than it used to be with older pumps. But you're still somewhat limited, and the recommendation depends on the manufacturer. But you don't want to start those pumps too often, be cycling them too fast, or you're going to burn those pumps out. So these are some of the sort of big questions that we'll look at when we go out there and we do a hydraulic assessment. So how do we actually measure how the pumps are operating? The big thing that we use is we'll conduct a fill and draw. So you can see we actually have a photo there on the right. It looks like a basketball. It actually is a basketball tied to a tape measure. And believe it or not, this is actually one of our preferred tools for doing a fill and draw. We'll also use, if there's a transducer on there, sometimes we'll use the transducer, but oftentimes we'll see that those pressure transducers are good to maybe a tenth of a foot. And so you have some uncertainty with exactly where it is. This basketball, we pretty easily get this to within a couple hundredths of a foot. So we'll use that to get a pretty accurate read on the water level in the wet well. So what we'll do is we'll turn the pumps on, and we'll draw that wet well down a known distance. Say we draw it down a foot. So we'll turn those pumps on, we'll start a stopwatch, and we'll time how long does it take to draw that wet well down a foot. Then we'll stop the pumps, and then we'll time how long does it take for that wet well to fill back up a foot. And for that pump, we know that if we know the area of the wet well, and then it was a foot, we get our volume, divide that by the time, and you get the flow, right? So you know the flow going out and the flow going in, and you add those two together, and that is your flow, because you've got to account for the flow that's coming in even as the pump is pumping out, and that's your flow rate of your pump. So this is it's a dummy check. You can use mag meters and all that stuff, but this is our bare bones check for let's make sure that we know what these pumps are pumping at, what rate are they pumping at. And we'll typically perform this twice with for every pump combination. So we'll do pump 1 twice, we'll do pump 2 twice. If there are multiple pumps or if there are combinations, we'll run those combinations. Right? We run pump 1 and 2 together and see what those are running at. Now, I'll add one caution: is submerged pipes. When you do a fill and dry, you've got to watch out that you don't have a pipe that starts submerging and is backing up water outside the wet well, because that's going to mess with your volumes. Typically, we try to run it below a submerged pipe. Typically, that incoming pipe, we can run it below there, even if maybe we'll operate the station a little bit lower than it doesn't typically, but that's really important to be able to run that below that submerged pipe. Otherwise, you're not going to get accurate readings. So I want to just give you a case study of when we did a hydraulic assessment. This here is the CV lift station, and we did some flow monitoring a few years ago for around this station. And during that, there was a big storm, and our flow metering data, we noticed that this lift station did not appear to be operating at its design point. Well, we followed up with a lift station assessment study to try to understand why are these pumps not operating where they should. And during that, we assessed that they appeared to be operating at 1900 GPM instead of 2600 GPM. So there were a couple of theories about why this could be. There was a downstream holding tank at the treatment plant that this pumped to, and it filled up during that big storm. So we thought at first maybe that the increased head on the pumps was what was causing the decrease in flow, and that turned out not to be the case. When we checked it out with when we were on site and calculating that, it just didn't make sense. That didn't explain it. Another theory was maybe the force main was corroded. It had been put in 40, 50 years ago, and it was iron. And force mains over time will tend to degrade, and eventually they need to be replaced. So, and if this one had needed to be replaced, it would have been about 2.5 million. So it was about a mile-long force main. So it wasn't a cheap job if this thing had to be replaced. But we noticed a couple clues while we were doing the hydraulic assessment. One of the first things is this lift station was running at 55 amps instead of 89 amps, which is what it had been measured about a decade before. We had records that it had been running at 89 amps. And this was curious, because if the force main had been the problem, if there had been some sort of blockage or increased roughness on that force main, we would have expected that amperage to go up, not to go down, because those pumps would have had to work harder to push it through there. The other thing we noticed too is we took pressure measurements on that force main, and you can see here we've got the that yellow line is the pump curve, and those red dots there are the flow and the pressure measurements plotted, and you can see that those actually fall below the pump curve. So that pump, apparently the pump was not operating. It wasn't the force main, but the pump was not operating as we would have expected it to. Well, that the city did a little bit of digging, and they actually ended up finding some pack slips from several years earlier. They'd replaced the impellers, and they replaced them 1.5 inches too small. Well, that 1.5 inches had nobody had noticed it, and it ended up costing them 20-30% of the capacity of this station. So this is actually a really interesting case study in being able to play detective work and kind of track down what was the cause of all this, what's causing that decrease in capacity. So what can you do in-house to help keep good records? And I always recommend to keep good records to municipalities, to owners, and regularly review them to see if anything's changing. So I recommend that owners will do a fill and draw on their station from time to time. Maybe every year, go out and do a fill and draw and see, are the pumps pumping the same as they were a year ago, and keep records of that. Many of you keep records of your pump run times, either in SCADA or by manually going out and writing those down. And that's also a good way to check on how are those pumps operating. If you see your run times creeping up, that's a sign that maybe something's going on there. Amperages. Either a few bigger stations will have built-in ammeters, and that's great. I love that. You can also just go out, take an amp clamp and put it around there and measure the amperage going to each pump. And just go out and do that every 6 months, and as part of your routine maintenance, and keep tabs on that and how that's changing. Pressures. If you've got pressure dials on your force main, write that down. Same thing. If you've got a flow meter, if you've got like a mag meter installed on there, keep records of that, because that's useful to be able to go and track that down. And if something's changing, then you notice it, and something's going on with your lift station, and you're ready to take action with that. So I talked about hydraulic assessment. The second thing we'll do with a lift station assessment is the structural and I&I assessment. So here what we'll do is we'll dive the wet well, and basically what we're looking at is this structure sound? Primarily the wet well, because that's usually the deep one. The dry well as well, if there's a dry pit, or any other structures there, but primarily the wet well. And we'll look at a couple things. One of the big things we'll look at is structural defects, but primarily H2S tends to be a really big one. You can see the photo on the right, that's looking down into a wet well, and you can see a little bit of spalling and exposed reinforcement there on kind of on the right there. And that's something that, as we're, this lift station is going to be rehabilitated or replaced, and that was something that we noticed when we went out there, and something we needed to address during the design phase. On the left was actually, this is an interesting story. We showed up at this was the park lift station, and when we showed up on site, there was this new sinkhole right next to the wet well there, and the owner had never seen that before. And when we looked into the wet well, we actually noticed the photo on the left there. There's this kind of flow coming between the cracks. You can see kind of dripping down into the wet well. Well, that whenever the pumps would kick on, it actually sent a few gallons a minute kind of streaming into the wet well. The pumps would kick off and it would stop. We said, okay, something funny is happening here. So the village actually dug it up, and they found there was a T connection that was that had corroded a little bit there, and that was actually causing water to leak out into the surrounding soil and kind of wash that soil into the force main, and had caused that sinkhole. So it's not exactly I&I, but so we'll keep an eye out for those kind of structural defects and what or I&I that's coming into the wet well. H2S is a big deal with lift stations. Probably more than anywhere else in your system, lift stations are one of the most likely places where you'll see H2S corrosion. And that can either be in the wet well, in the force main, or downstream of the force main where it discharges. So it's a big deal to keep an eye on your stations and know what kind of H2S problem do you have. I'll give you an example here. This is a manhole from Joliet, and this is it was a multiple mile long force main that discharges into this manhole. You can see the discharge pipe in the left hand photo there, kind of just below where the flashlight's pointing. And we had gone out there we'd gone out to this manhole a few times, and noticed that you can actually see where the flashlight's pointing. There's this hole in the wall of the manhole, whole void visible. There's this void behind the manhole there. So we knew this manhole, plus you can see the chimney there of the manhole is all eaten up. We knew this manhole was in really bad shape, needed to be replaced. The city was going to do this in a couple years, because it's actually designed right now to replace the interceptor. But came out a couple months later, and this big sinkhole had formed next to the manhole. That hole that you see, the whole void visible, the wall had actually collapsed in there, and all this soil had come into the manhole, had washed in, and the wall was shot. There was nothing left of it. There was about 2 or 3 inches left on a whole lot of this concrete block manhole, and so this whole structure needed to be replaced. But this is really just one example of the magnitude of the corrosion that can go on at a lift station. In this case, downstream of the lift station. Usually you'll see it several manholes downstream, and then it tends to dissipate as that H2S comes out of the water, and the water is kind of aerated again after being in the force main. But just something to keep an eye on at your lift stations. All right, so we've done hydraulic assessment. We've talked about structural and I&I assessment. The last thing I want to talk about is operational assessment. So here what we'll do is we actually use iPads to go through, and we'll go through a whole checklist of questions, as well as making general observations about each of the major systems at the lift station. And by the way, one of the cool things that we're able to do with this, because we take all this data electronically, this is all visible through RJN Online. And some of you have maybe seen this before, but this is sort of the interface of it, and all that data, along with smoke data, manhole inspection data, lift station inspection data, also is totally visible there online. So you can just pull up the report and see all the data that was collected for this lift station, all the photos that are collected. So all of this that we do here on the checklist feeds into RJN Online, so it's all visible to you after we come out there. So I'll take a few minutes and let's go through some of the things that we look at as we go out. And every lift station is different. So we'll, sometimes it takes a little bit of creativity to look at all the different aspects of the lift station. But we'll usually start with general info, right? So you'll go out and you'll ask, what's the dry well? Or does it have a dry well? Does it have a wet well? Does it have a valve vault? Maybe a meter vault or a bypass vault? What's there? What kind of structures? Does it have a history of excess flows during wet weather? Right? When it rains, do you start running multiple pumps? Are there backups upstream? What's the construction history of the lift station? When was it built? When, has it been rehabbed since then? Where's the old structure and what was built to go where when it was rehabbed? When were the pumps replaced? That sort of thing. We'll look at the hydraulic systems. So how many pumps do you have? How many horsepower are they? Are they above ground? Are they recessed? Are they dry pit pumps? Or are they submersible pumps? More and more we see submersible pumps. That's kind of the new trend, but there still are. This is here on the right is an example of a recent station that was redone, and those are suction self-priming suction lift pumps. So especially for bigger pumps, you'll see that more often. Look at force main diameter and force main material. Force main age, which helps us know what the roughness is. We'll look at the different control systems. So what sensors do you have in there? Often, kind of the newer trend is to have a pressure transducer in there, or sometimes an ultrasonic, but to also have backup floats just in case. What do you have set up for your control panel? We start to see more PLCs nowadays where you can actually set those set points up electronically. You'll also see old ones where it's just run manually off of floats too. Are there VFDs or soft starts? What are those set points? Where's the low water alarm? Where's the high water alarm? Where's the lead and lag off and on? And how does all that logic set up for the lift station? Is that actually working? Are those set points set too close to each other? One of the things I want to talk about with control systems is talk a little bit more about lift station monitoring. So I'll pause here for a sec. Talk about what are a few of the ways that you can actually monitor your lift station. One of the big ones is SCADA. At this point, I'm not going to say all of them because I know there are still some out there that don't have this, aren't set up for this, but I would say most lift stations are set up so that if a high water alarm goes off or some major alarm goes off on the pumps, the operator on call is gonna get a call and have to acknowledge that through the SCADA system. And that's awesome. We love to see that because that helps you guys be proactive, going out there and staying on top of your stations when something goes wrong. So SCADA is a big one. I want to emphasize that as one way to monitor. One thing SCADA doesn't do is it doesn't actually capture the flow going through your station. Generally, SCADA will measure. Most of the time we'll see it set up to maybe measure pump run times. Sometimes that's set up in SCADA. Occasionally, so then there are also a few options too to measure the flow that the lift station is pumping. So one big one that we see is a mag meter. Some stations have this. Some of you guys have this. It sort of you have to cut in the pipe and put a kind of a new pipe in there, and then it measures the flow going through there. And its mag meters are pretty accurate, but one of the downsides is they're pretty expensive. One of the cool options we've seen to replace a mag meter potentially is VoluCalc. This is one name that I've worked with a little bit, and the VoluCalc, basically what it does is it measures the flow going into and out of your lift station by two ways. It knows you'll tie the level sensor in the wet well, either pressure and ultrasonic. You'll tie that into the VoluCalc, and then you also it comes with amp clamps to put around your pumps, so it knows when each pump is running and what amperage it's running at, and then that feeds in there. So then the VoluCalc is actually able to calculate real time and 24/7. It's basically doing the same thing that we do when we do a fill and draw, right? It knows how far did that level get drawn down, how far did it come back up, and it knows which pump was running. So it's able to real time calculate what are the flows, and you can go back and look at this for for months. What were the pumps actually pumping at this month? It can detect things like quick starts where maybe that pump's turning on for a couple seconds and then shutting off again. We actually at one of these at one station that we went out and saw, the VoluCalc had actually picked up. We noticed that it was the level sensor for the station that was controlling the pumps had some problem when some foam had come through the station. The station sometimes got some foaming, and that ultrasonic had kind of been confused with the foam and was turning those pumps on and off really quickly. And so we told the city to keep an eye on that, so that the pumps wouldn't start and stop too rapidly and burn themselves out. So this is a really cool option. We like VoluCalcs, and I'd be happy to tell you more about that if you're interested. And then the last option we'll sometimes use is our standard AV meter. If you go to the discharge manhole, you can stick that band up there. Here's an example of one of those in Orland Park, and we'll stick that up there, and we get the velocity and the depth, and you can calculate the flow that way too. So that's a good option for temporary flow metering. Just to wrap up real quick, we've got a few more systems too that we'll take a look at on our checklist. Mechanical, electrical, HVAC. Kind of looking at some of these systems. Do you have a backup generator? Just how is everything configured, and is it working for you, the owner and operator? What kind of maintenance is performed at this station? Do you have stuff on hand for if something goes wrong? Are you doing regular maintenance on your pumps? Are you regularly operating your valves? And especially air relief valves. Air relief valves are a big deal. Are you going and looking at your air relief valves and maintaining those and making sure those are working on your force main to keep air out of there and minimize corrosion of your force main? And then the last thing we'll look at is an emergency plan. Do you have an emergency plan for your lift station? And here are 3 things that I think everybody needs to think about for their lift station. So number 1, what if the power goes out? Do you have a backup generator on site? Do you have like a portable generator that you can bring and plug into a tap, or maybe a portable pump that you're going to need to bring and bypass? So do you have a plan for if the power goes out? Do you have a plan for if your pumps fail? So IEPA requires that you have a pump, that's always in standby, that you can in your wet well, that you can use to, if one of your pumps fails, you should have that extra one that can automatically kick in. But do you also have portable pumps? Do you have a bypass valve? And then the last one, and this is often the hardest, is what happens if your force main breaks and it takes longer to fix it than you want to, or maybe there's a serious clog in it. Are you able to bypass that force main? Maybe if it's a really long force main, you've got to think about, is there another nearby manhole where you could reroute that? Maybe you have Rain for Rent or another pump rental company on call with actually a plan where they can come in within a few hours, set up a bypass for you. Or are you going to have to bring out tanker trucks and try to bypass it that way if it's a low flow station? So there isn't always an easy answer for all these, but at least having thought about it and having ideally a written out plan for each of these 3 contingencies, for what your plan is for each of your stations in your municipality. And then after the lift station assessment, so we've looked at all 3 of these things. what's next? Well, sometimes it's maintenance. You know, maybe we call it a pump is not operating as well as the other pump. And so maybe, you know, one of the pumps or both of the pumps need to be maintained a little bit. Maybe they need some new impellers. Those tend to wear after several years. You know, yeah, every lift station's different. So we pretty much always have different recommendations from when we go out there. Maybe one of the next steps is force main assessment. I really haven't talked much about force mains because Andy and Kathy are going to talk about those in a little bit more depth. But let me just say, force mains are huge. Those are a huge piece of your lift station, and knowing the condition of your force main is huge. Sometimes that gets called into question when we're doing a lift station assessment, and so we'll flag that as a follow-up, maybe doing some kind of assessment on your force main. And so with that, thank you for letting me present, and I'm going to invite Jan Gallen up to talk a little bit more about rehabilitation and design of your lift stations.